We are green. Okay.
All right, excellent. Here we go on the final day.
Oh
I
boy.
will turn the phone over to Carter. Today, it's our first stream of the day. We'll be doing about 20 minutes, 25 minutes here today. And then we'll have one final live stream this afternoon from 1:30 to 2:30 Central Standard Time. I do want to just thank Carter for taking time all this week to do these presentations for us. So Carter, thank you so much. And I will let you have the floor and take it away from here.
Thanks, Adam. We're about to see OpenSpace in just a second, streaming to YouTube. Should be picked up in just a moment. There we go. Yay. So OpenSpace is an interactive data visualization tool that is supported by NASA SMD. And insofar as being supported by SMD, we pertain to the major divisions of science within NASA. So we visualize across the universe. We focus on Earth science, helioscience, planetary science relating to this current conference, of course, and astrophysics. Innate to open space is the ability to sort of go from across scales, somewhat agnostic. And we'll preview that for you here. When I bring OpenSpace up, it loads with a current image of the Earth. Here we are of today. However, what we're actually seeing actually is today the 18th or 19th. Like it's been a rough week. It's the 19th. Okay, I'm actually set on yesterday's image. My apologies if I'm a little punchy. It's just going since I woke up with meetings. Natively, what we see here are images that are pulled from NASA Goddard from their Global Imagery Browse service. We're looking currently at the SUMI NPP VERS instrument, which creates a global mosaic. You may actually see the sun's glint. Let's see if my cursor is on screen. That's actually that'll work for me now. There are other things. There's other information which I'll just clear off the screen. We don't really need it, the altitude and so on. But if you follow my cursor, you can see the sun glint off the ocean. Of course, this global image, which has been taken from low Earth orbit, the orbit you see here is that of the ISS that I'm just showing currently. But this is the SMPP satellite, along with the other NASA birds, Aqua and Terra, that are in low Earth orbit, of course, build up a daily portrait of Earth in gores or in sections from their near polar orbit. And we can actually see the effect of that of the sun glint off the ocean. And by getting close enough between these, we may actually see kind of a temporal discontinuity between layers in the clouds that one might see. I can kind of see it down here across the Amazon basin. Okay, so we'll pull out, one of the features of open spaces we're focusing on is to really sort of plot all things. In this case, we have the a set of satellites. This is not the full complement that we pull from. But I'll slow this down to 5 minutes per second so we can see the low Earth orbiting satellites, and then pull out. We see of course, the geosynchronous belt around Earth, and in between mainly GPS satellites. We operate with this notion of visualizing trails. And so that blue line is the Earth's trail, of course, around the sun, and the trails of the other planets. Now, before I go any farther, I'm going to call our attention to the moon in a second. We'll go there. In fact, lunar orbit, I'll bring up, is that OpenSpace is an academic collaboration. I haven't even mentioned that yet. Between the American Museum of Natural History, of course, in New York. This is where the science activation grant is sort of based with our museum. I'm a co-I on the grant. Our principal investigator is Dr. Rosamond Kinsler. She's my boss. The reason Earth's is cleared because I have time lapse going, and we went to today, and so today's mapping, we may see a little bit of it over here, but I'm actually operating on a cache right now. So allow me here just to have something on screen while I'm talking. So I'll go back. There's another layer that was errantly loaded. Okay, I'll just clear that off and let the Earth turn. And as the date line goes past the central meridian, we may see time change. In fact, here I was missing actually a slice of data, caching it for showing. So we are out of the Museum of Natural History, but OpenSpace it really became a project as a collaboration prior to SciAc funding. Science Mission Directorate, or part of the Science Activation Program in Science Mission Directorate. Prior to that funding, I've been collaborating with Sweden's Linköping University, one of the world's leaders in data visualization research. When we were funded, that enabled further collaboration with arguably the world's largest data visualization research facility at the University of Utah, the Scientific Computing and Imaging Institute, and then also with some of the people that had worked there, started visualization group at New York University's Tandon School of Engineering. So we are 4 centers essentially, and an international collaboration. So let's show what we can do with OpenSpace. I want to target the moon. OpenSpace operates on basically selecting a target and going. I'm going to come out past 10 times the distance of just synchronous out to the moon. And to do this, what I'm going to do, actually, Mars is kind of our next destination, so we'll see that. But with the sun in the picture, I'm obviously turning off realistic lighting. I've turned off, I've just turned on basically lighting to glow the moon from the, you see the continuous full global mosaic of the wide angle camera from Lunar Reconnaissance Orbiter. I'm coming in close just to show you sort of the range and capabilities here to LROC mosaic of the Apollo 17 landing site that was made available from the U.S. Geological Survey in collaboration with the German DLRs. This is by Haas et al. And so we're seeing this characterization of the Apollo 17 Taurus-Littrow region, both in elevation as well as a seamless LROC mosaic, which is quite nice. It's about 1 meter resolution. They provide full resolution insets of basically the station locations that were investigated. Here, Station 6 on EVA-3, our last moonwalk. And I'm going to come up close. We do see they provide a nice little sort of scale in here. And then I'm going to come close to photogrammetry that was done with the Hasselblad pictures that were taken on EVA by Jack Schmidt and, of course, Gene Cernan. And we used reality capture. In fact, this was done by my high school student, Sham Tagaraj is his name, from the Bergen County Academies, top placing high school in the New York tri-state area. And so, you know, a program of working with these students, they do a variety of interesting and fairly challenging tasks for high school students, but have added a number of things for OpenSpace. And in this way, we can look at the boulders of Station 6. Of course, the photogrammetry solution has holes so that we don't see everything. Actually, I still want to position these a little better to get the arrangement just a little tighter. But nevertheless, a lot of this is work in progress. We have other boulders from other station sites. I have the lunar module, so if I just come down here, I'll show you just within, there's a lot in OpenSpace. If I actually just close down the details for fragment 6 that are available to us, we can see, or Station 6 fragments, that we see how we organize OpenSpace into solar system, Milky Way, and universe. Again, covering this sort of range of topic areas that I mentioned. But we can do a simple search. I'll just say LEM, and it's the Apollo 17 LEM. It should be LM, not LEM. But nevertheless, let's come in on Challenger. This is a photogrammetry model based on LEM-2 on display at the National Air and Space Museum. I took about 2,000 pictures, literally, with my iPhone 6, and Reality Capture created the nice representation of the LEM put at scale within the LROC 25 centimeter resolution image. So we can clearly see here the lunar rover's parallel tire treads, but we can also see the foot trail paths back and forth to the ALSEP station and beyond. We're not doing any vertical exaggeration, so we're representing all that properly. Okay, so I'll pull out from Apollo 17's landing site. We have different global maps we can use. We also collaborate with other science activation partners. Namely, some of you may be familiar with NASA's treks. There's Moon Trek, Mars Trek, and different treks for different bodies, Ceres Trek or Phobos Trek. But let's go off to Mars. So we can basically take data that other partners are gathering and aggregating, and then bring those into OpenSpace. Okay, that was sort of my point about that. We also work with mission visualizations. We're actually working from NASA's spice kernels. I'll just bring up my menu so I can select Mars before we go off to that. We do mission visualization, and usually within a brief presentation, such as we're doing right now, that I'm not focusing on that. But we've done some elaborate mission visualizations with New Horizons, with Rosetta, with others, where we show sort of the image frustrums, and then the images that were gathered, we can image project in place, and so we can show how missions are actually done, satisfying not only the sort of science that we want to talk about, but also STEM in the sense of the engineering that goes into this. We come up on a Mars that admittedly looks kind of low resolution here. This is our base color layer. And if I do this, I'm going to add in the Viking mosaic on top of that. If you're familiar with the Viking global mosaic, it has different coloration to it. We are applying our coloration, blending it in with theirs because, we kind of felt that this was perhaps more representative color. From a number of different color sources, I could talk about that for hours, we can see the Tharsis Montes and Olympus Mons sticking up through the atmosphere. The atmosphere is a physics-based scattering model for Rayleigh and me characteristics. We apply that to Earth. You can apply that to Mars, Titan, other worlds. And so let's just come in a little closer. What I'll do is now actually where the Viking mosaic sort of reaches the edge of its limits, I'm going to bring up here. Okay, I have focused on Mars. Fine. So, if I just close the limb, I'll have Mars. My menu's open to that. My layers, I have image layers here labeled as color layers, and then we have elevation, height layers. Many different things. I'll bring on the blended CTX map by Murray Labs from Jay Dixon at Caltech. And one of the things I'll just call out because we see it as almost like an artifact here. In fact, I actually I had time moving, so I'm going to stop time. I'll go back in a second. But you can see these sort of latitudinal contrast bands. This is a beta version. Jay was very gracious in allowing us to use, but it's not the most does not represent the most current work. So we have an update to do. What I'm going to do is just step back a few hours here to bring us into a good lighting scenario here, and I'll go one like so. Okay, and time is paused. That's good. Clear all this out. And as I come closer, let's look at Valles Marineris down to 5-meter resolution that CTX allows. As I get closer, we can see over here in Melas Chasma, I see some strips, but I always like to sort of come over into Western Candor. Again, I'm running this from a local cache that I did just for expedience sake, so that I wasn't going to get into issues of having to wait for tiles to possibly page in. And there's a lot of data that I'm looking at. I think part of my stuttering we're seeing is the fact that I still have the Viking map turned on. So I'll turn that off as well. It allows me a little bit nicer control. Still having some issues. But I've purposely kept the high-rise terrain down here visible just with slightly lighter tonality to call it out. So let's come on down into that. So what we're seeing here elevation-wise is the 200-meter MOLA plus high-resolution stereo camera data product from the USGS. That is being served by Esri Company. Then we have the CTX also being served by our colleagues there, as well as the high-rise and our high resolution Earth maps, also by Esri. But we also have servers within the OpenSpace constellation of academic sites at the University of Utah and also at Linköping University in Sweden. Coming down, no vertical exaggeration here. We see wind-carved Yardang features, also eating away at the sulfate layers we see in this area of western Candor Chasma, Sedimensa area. We're looking out at about 5,000 meter background to the edge of the walls of Candor Chasma. But up close, we see up to a few hundred meter height of the nearby hills. We see sand dunes over in the lower right. And of course, we saw earlier, and I'll just recompose here to see basically the exposed sulfate layers in this region. The beauty of the stereophotogrammetry that can be done from high-rise is extraordinary. We collected all of those that were available about a year ago that are currently being served from Esri. And and there are new ones. Either we update that or we can cherry pick data sets that we want to see and put them into this GDAL-based globe browsing system. And so it's about 20 after. I just thought I might see if there were any questions after this very quick tour of some basic capabilities within the planetary science realm of OpenSpace.
Yep, I don't see any questions currently.
Has anyone been watching? Have we had any viewers?
We've had a couple of viewers, yep.
Okay, that's good. Well, I'll finesse this just a little bit. If we look over at the 200 meter resolution maximum within this combined MOLA and high resolution stereo camera results, that we're not picking up on features of this scale that we see here in high rise. In fact, if I rise up, however, and look down at the adjacent 5-meter CTX imagery, we do see there are, of course, hills on that, roughly on that scale. Because of this and our desire to contextualize the high-rise imagery, or the high-rise terrain modeling, with something better than the global elevation maps, we do regional mapping using the NASA AIM stereo pipeline with CTX. I actually have my high school students working on that. And one of them has gone on to her PhD work, Paul Lucy at Hawaii, and Kiara Ferrari Wong. She had a poster at LPSC. Janie Levin, who is still finishing up at Columbia, but is also choosing to go into a career track in planetary science. I'm very proud of them for this. They sort of, I think, got the taste of some of this in their internship with the museum. So let me actually turn on now an elevation map done by those two individuals I just mentioned. So let's come down here, Western Candor 2019, and let the map read in. This is a map that I actually have on disk, and it's still loading here. And the level of detail is, has to sort of come in by pausing over the terrain. So it's going to cull to the view and start to read that in. Now, this resolution is, it's what it is. It's probably at best about 20-meter resolution. So almost hard to compare to the superior high-rise adjacent. But considering that prior to invoking this map, I wasn't seeing any elevation detail in the surrounding area, it's actually pretty good. And then when you consider that the high-rise is really just a very small portion of what we're looking at, the regional CTX elevation enhancements actually come in quite handy in investigating the broader area of SETI Mensa and beyond. And so let's just take a moment and fly over to this far corner of sort of the northwest. We were in the southwestern Candor, and if I just come over here, I'm laboring a bit just because of the amount of data that I'm actually reading off on disk and throwing into the system, visualized on the fly in OpenSpace. I'm particularly fond, as I come from an artistic background, an artistic family. I sort of grew up going to the old Hayden Planetarium, and so it's been meaningful to me to sort of have a career at the new planetarium, where the goal was to go from basically star shows, sky shows, to shows that we renamed the Hayden Sky Theater to the Hayden Space Theater, because we can really sort of take you with data visualization to all these places. And really being able to investigate Mars one-to-one scaling and getting a view of what these places really look like, and share that with the public is rather profound. I mean, you consider we're just seeing this on a small window, but you put this into a display like we have with the 70 some odd foot diameter dome at the Hayden is 68 feet. But anyway, who's counting? That with about 400 seats under it, is that we can take everybody to Mars. And not have to worry about perchlorate or or any kind of malfunctions and things like that, is that at least we can represent Mars in ever greater visibility thanks to our missions there. So once again, I don't know if there are any questions which I want to answer if there were.
I don't believe so. I would say at this point we can wrap up for the day, and we'll get back to it at 1:30 Central Standard Time.
Okay, great. Excellent. Very good. Thanks for your attention, whoever may have been watching. And if you're interested, I did not even mention this. OpenSpace is free. It's a NASA NASA-sponsored project. Download it from OpenSpaceProject.com. I usually try to say that at the very beginning of the talk, but OpenSpaceProject.com. You can download a version that works in Windows or Mac right off the bat. If you're so inclined as a Linux user, you can compile it. We have a GitHub site, our wiki. We have a YouTube channel. Our wiki available from our website also has a list of links to all our academic papers, because a lot of what you see here are the result of senior thesis projects from the students at Linköping University. That said, the code is then basically maintained by about half a dozen developers who are working on this full time. And and we're also our partners, institutional partners, are the Adler Planetarium in Chicago, the Morrison Planetarium at the California Academy of Sciences in San Francisco, who are doing weekly broadcasts with OpenSpace right now in the pandemic. We are doing monthly shows at the American Museum of Natural History. Also, the Burke Baker Planetarium in Houston, and close to the grounds there of Lunar Planetary Institute, not far, and so on. Also, the North Carolina Museum of Natural Sciences, where they don't have a planetarium, but their curator, Rachel Smith, is a good friend and astrobiologist, really, but also geologist, lunar investigations, and is attending the conference as well. We've had a poster as well with lead author Marina Gemma, who's a graduate student with us. So you can check that out as well. Thank you for your attention. And if you're interested in more, we'll be back up in about an hour.